Sketch the curve with equation y equals 7 to the power x, indicating the coordinates of any point where the curve intersects the coordinate axes. The curve C1 has equation y equals 7 to the power x. The curve C2 has equation y equals 7 to the 2x minus 12. By forming and solving a quadratic equation, prove that the curves C1 and C2 intersect at exactly one point. State the y-coordinate of this point. Use logarithms to find the x-coordinate of the point of intersection of C1 and C2. Give me your answer to three significant figures. So let's have a look at it then. This should be 7 to the 2x here, shouldn't it? Put that in. Okay, so I've summarized the question here. So sketch this curve first of all. Let's do that then. Quick sketch of the axes. Just do a quick sketch here. That will suffice with this digital pen. Okay, there's the axes then. X, Y, 0. Y equals 7 to the x then. Let's have a look at it. Okay, so it's 7 just shoots up bigger and bigger and bigger. I'm going to use dashed lines to draw the curve. Here it is here, and it goes to 0. As x goes to minus infinity, shoots off to 0. As x goes to infinity, it shoots to 0. Cuts the axis here when x is 0. 7 to the 0 is 1. So there's the coordinates. Indicate where it cuts the axis, which I have done there. I'm just going to emphasize that by putting that to be the point 0, 1. Okay, C1 is that. C2 is this curve. Prove that C1 and C2 using form a quadratic and cut at just one point and find the y value. So let's have a look at B then. So here, what have we got then? We've got y equals, so let's sub this in here. This is 7 to the x squared, isn't it, using properties of indices, minus 12. And put the other y value in, y also equals this. We can replace the 7 to the x. So it will be y squared minus 12. So that's a quadratic then, which is what the question asked us to form. So we've got y squared, move this y over, minus y minus 12. So everything's moved over, and I've written it down from right to left. I moved the y over to minus y here to be with these two terms. So factorize. Okay, let's see what we've got then. Here we've got, what have we got then? Y equals 4 3's, so 4 and 3. This will be a minus, this will be a plus, because that's a minus, isn't it? So y squared, minus 4 plus 3 is minus y, plus times a minus is a minus 3/4 of 12. So that implies the y values are all positive, so the only value that's relevant here is the y equals 4. Since y is positive, okay, so there's just one solution when y equals 4. So we've got y equals 4, and use logs to find the x-coordinate now. So let's sub that in one of the equations. We'll sub it in the easier one of the two, 4 in here. So this is part 2. Here, y equals 4 is equal to 7 to the power x. So let's drop this down to be the base and write this in log form from right to left. So this drops down to be the base, log 7 of 4. And I've written it from right to left. So the x drops down to ground level, equals, the 7 comes down to be the base of the logarithm. We need this to three significant figures. Log base 7 of the number 4 equals three significant figures, 0.712. And that was to three significant figures.